Hello, good evening guys. How's everyone doing? Can see a few people have started to join. Can everyone hear me okay? Hello, Geordie. Hi, Jesse. Nice. Okay. Cool. Now that a few people are here, we'll make a start. So, welcome. We're doing another exam walkthrough today. And today it will be on waves. So, we'll be covering a few questions on a few different topics. So, transverse and longitudinal waves, properties of waves, and electromagnetic waves. We'll take a look at some of these exam questions today. So it's purely a question session, obviously a bit interactive with you guys. So any answers you guys have, put them in the chat. Don't be afraid to be wrong. It's the whole purpose of this is to get some practice, and practice makes perfect. So don't be afraid to get it wrong. We're here to learn, and it makes it more interesting for all of us. So yeah, feel free to put your answers in the chat. So following this, after this session, I'm doing the questions on these topics because we'll be doing a content masterclass on this on Sunday. So hopefully if you want to learn more on it and go through the actual notes, make sure you join the class on Sunday. So without further ado, I will head over to physics. You can see it's nice and bare at the moment, the dashboard, but as we do some questions today, when you do quizzes, these will fill up. But today we're just focusing on exam questions, so that won't change for now, but that's fine. So if I go to transverse and longitudinal waves, how do we know when the next classes will be, Geordie? So I can quickly show you on the website. You can go to live classes, and if you scroll down to the bottom, you can see here the list of classes and with links to join. So if you had access to our FRL Pro Trio package, you can see all the classes. FRL Pro Solo, you'll only be able to join the particular subject that you sign up for. And free users, you can see them all, and then it will take you to a link to pay for a particular class if you just want to join a one-off class. Yeah, so that's how you see it. The walkthrough is exactly what I'm doing at the moment. It's where we're going to be going through some exam questions like we will today on the topics that we'll then go through on the Sunday content masterclass. Okay, so let's take a look. Transverse and longitudinal waves. So our first question. Figure 1 shows a water wave. What type of wave is a water wave? Tick one of the boxes. So is it electromagnetic, longitudinal, or transverse? Who thinks they know the answer to this one? Any ideas? The different types here. Electromagnetic isn't necessarily a specific type of wave. It's also actually an example of one of the types of waves. Geordie Chiba said transverse. Anyone else? Any other answers? Transverse and longitudinal referring to how the wave oscillates as it transfers energy. So Geordie is actually right. It would be transverse. So I would just go and tick this here. Transverse is correct. Water waves, electromagnetic waves is actually an example of a transverse wave. Longitudinal, you would be looking at things like sound waves. Okay. Which statement describes the movement of the water at point X? Tick one of the boxes. So the water at point X does not move. The water at point X moves to the left and right, and the water at point X moves up and down. So in part A, we've obviously established that it's a transverse wave. So knowing the definition of what a transverse wave is will help you to answer this question. Does anyone have any ideas? can say 1, 2, or 3. I know they're pretty long, so you can say 1, 2, 3 or ABC. Which one do we think is right? Okay, we've got one answer up and down. Anybody else agree or disagree with that answer? No? If someone said left and right, okay, so we've got a variety there between the two. So, a C, okay, so we've got a couple of people for up and down, one person has said left and right. So the correct answer is the water at point X moves up and down. A transverse wave, so the oscillations are up and down as the energy moves from left to right, yeah, so perpendicular to the wave direction. Whereas for a longitudinal wave, that's where the oscillations move left and right, Geordie. So left and right would be for a longitudinal wave, but in this case, it is a transverse water wave, so the answer is up and down. Okay, moving on to question 2 here. So figure 1 shows a longitudinal wave. And it says, what do the labels A and B on figure 1 represent? Okay, good, Geordie, no problem. It's okay to get things wrong, as I said, so that's fine. I'm happy that you're just answering these questions and getting involved, so it's good to see. So again, what do the labels A and B on figure 1 represent? So you have A here, where the particles are more kind of spread out, and B here is referring to the 2 points, or the 2 sections where the particles are closer together. So we have amplitude, frequency, rarefaction, reflection, and wavelength. So B wavelength I've got, so that's for this distance here. That's correct, so I'll put that underneath here. So this is, wavelength. That's correct, yeah, wavelength, otherwise known as the distance between 2 repeating points on a wave, or the simple way to remember it before that is just the length of one wave. Correct, so B is the wavelength. What about A? Arguably the slightly more difficult one out of the two. Frequency, we've got frequency written there. Anyone else? Anyone else have any answers for that? So frequency actually refers to the number of waves that pass a point per second. So we don't have any indication of time on the drawing here, so that's not correct, I'm afraid. Amplitude, again, amplitude is actually to do with the distance from rest position and peak of a wave, so it's actually to do with a transverse wave amplitude. It's a transverse wave property. They've told us that this is a longitudinal wave. So Geordie, sorry, that's not correct. I see an answer for refraction. Refraction isn't the option here, it's rarefaction, maybe just an error in spelling there. But rarefaction is the correct answer. So a rarefaction is just a point on a longitudinal wave where the wave is essentially kind of stretched. Yeah. So the example I always look at when looking at longitudinal and transverse waves is like a slinky spring. So you can hold the slinky spring at one end, and if you push the slinky backwards and forwards, you get bits where the slinky springs are closer together and then bits where they're more spread out. That is what this wave is showing. So where the particles are closest, like when the slinky is really, the springs are close together, and then here where the springs are spaced out. The spaced out part is called a rarefaction. For a transverse wave, hold the slinky spring at one end, and instead of pushing it backwards and forwards, lift it up and down, and then you get a wave style pattern that we saw earlier for a water wave, and that is a transverse wave. Okay, cool. Question 3 then. So, figure 1 shows a slinky spring used to model a sound wave. There we go. Didn't think that was coming up. This wasn't planned. Label the arrows on figure 1. Choose the answers from the box. So kind of similar to what we saw earlier. I think the first one should hopefully be a bit easier. The first arrow on the left, what would that be? I'm pushing the slinky backwards and forwards. Do the slinky springs look close together or further apart? And what did I say that means? Rarefaction. Yes, Geordie, correct. Yeah, so the spread out part of this is a rarefaction. Okay, and then what about for the bit that's pointed on the left here? So you can see here the springs are actually closer together, whereas here they were spread apart. There's a word there that kind of suggests a word you'd use when something is close together. Yes, compression. Yeah, exactly. Yeah, so when something is close or kept close to each other, compressing is like squashing. That's what it looks like there, right? So that indeed is a compression. Nice. And then it says, what type of wave is a sound wave? So I mentioned this earlier. Someone has mentioned wavelength. So wavelength wouldn't be correct because a wavelength is, oh, sorry for this one, apologies, I missed that. I'm looking at the top here. So yes, correct. The top is a wavelength. Yeah, as we saw earlier, it's the distance between two repeating points. In this case, two compressions. Yeah, it could equally be the distance between two rarefactions. So yeah, apologies for that, I just missed that. So that is a wavelength, correct. Nice. So on to the second part of the question. What type of wave is a sound wave? Yes, random, this is physics. So this is chapter 6 of physics, which is in your paper 2 for your exams. What type of wave is a sound wave? Electromagnetic, longitudinal, or transverse? So got a shout for longitudinal. Yep, a couple of shouts for longitudinal. If you were here earlier, I did say this, and that is correct. It is a longitudinal wave. Nice. And again, as I said earlier, electromagnetic is a type of transverse wave, and transverse is obviously different. As we mentioned earlier, the vibration or oscillations are perpendicular to the wave direction. Okay, so we'll move on from this for now, and we'll go on to the next topic. So if I scroll up, we'll go to properties of waves. So as always, like we've seen here, if there's anything that you're unsure on, you can always go into the notes and then revisit the question and then take in your answer or look at the mark scheme and check. So don't worry that it's something that you can't go back to. You can always come back to the notes and review them. Yeah, it's a great tool to kind of check your notes as you do the questions, and then hopefully as you get used to it, you'll be able to then tackle the questions without needing the notes at all. But it's all there for you to kind of help you answer these questions and get ready for your exams. Geordie says, how many types of wave do we need to know? It's the main two types of longitudinal and transverse. Those are the two types of waves. We then later go into the properties of those two waves, which is what this topic is about. And then also, when I mentioned electromagnetic waves, that is just a type of transverse wave. So we discuss those in a bit more detail. But the two main types of waves are longitudinal and transverse. Cool. So if we go to question 1 here, figure 1 shows 4 waves. The waves are drawn to the same scale. Which wave has the greatest amplitude? So does anyone have an idea as to which this would be? So Tina said A, Adnan said B, we've got another A. Okay, so it's a little bit of a mix of answers there, but most people have said A. And if you did, you are correct. The reason is amplitude, I didn't select the pen, apologies. So amplitude is to do with how the distance between the rest position, so the position that if the wave wasn't vibrating, where would it sit? And roughly, if I draw a line, it's around about here on the wave. Yeah, you can see that's kind of the 0 point. Then the amplitude is the distance between the peak or the crest of the wave and this rest position. So essentially, the taller the wave is, the greater the amplitude it's going to have. Yeah. B refers to a higher frequency. The waves are closer together, so we might see that shortly. And we have. I've gone ahead of myself. Which wave has the greatest frequency? So I'll answer that question. That is B, and that is because the waves are closer together. As I said earlier, a frequency is the number of waves which passes a point per second. So if you see more waves, that means the frequency is higher. If you see less of them, the frequency is lower. Okay. So the greatest frequency is B. Which wave has the greatest wavelength? D, B. Okay, quite a variety of answers actually. So no one's completely sure as to which one it would be. Now, if we talk about what the wavelength is, the wavelength is the quick way, as I said earlier, to remember it's the length of a wave. It's the distance between two repeating points on a wave. So that can be from, for example, peak to peak, crest to crest, trough to trough, from one 0 point to where it then repeats itself again. Yeah, so any two repeating points. For it to be the greatest wavelength, you want those repeating points to be as far apart as possible. So that automatically rules out things like B. B, they're really close, the frequency is high. If the frequency is high, the wavelength is low, and vice versa. So the correct answer in this case would be D for that reason. Here, this is just showing literally one wavelength. In part C, we can see two wavelengths, same for A, and then B we can see several. So the one that has the greatest wavelength is D. Okay, now a favourite in physics, sorry about that, I'll remove the writing there. Calculations. Yeah, a lot of physics has calculations. It's tightly related to maths, plenty of equations. As you do more of them, you'll commit them to memory hopefully. So let's take a look at this one. A wave has a frequency of 1650 Hertz and a wavelength of 0.2 meters. Calculate the wave speed. And it's told you that in this case, use the equation as well. So they've given us the equation. Wave speed equals frequency times wavelength. So we're given the frequency and the wavelength. So that means that to calculate the wave speed, we simply need to substitute the numbers into the equation. So that would mean wave speed, I'm just going to use V for short, equals our 1650 Hertz multiplied by our 0.2 meters. If anyone has a calculator on them, that would be great. Can anyone tell me what the answer for this would be? $330. That is correct, 330. Okay, I'll go on to the next question. So the student uses a mobile phone app that displays sound waves. Figure 2 shows how the student holding the mobile phone close to a loudspeaker. Figure 3 shows the wave pattern seen on the phone screen. What is the period of the wave shown in figure 3? So period refers to the time taken to complete one full wave. I'll just zoom in a bit there so you can see that a bit better hopefully. So it says the period, or otherwise known as the time period, is the time to complete one full wave cycle or one full oscillation. So an oscillation, as I said, similar to the one wavelength, is the point from when a wave starts to when it repeats again. So you get one full cycle before the wave starts to repeat. So in this case, we're going from 0 and to the point. So someone said 0.002. So I think you've probably said that because it touches 0 again. So the problem with that is it's not a repeated point, because initially the wave is at 0 and it's going upwards. So for it to be a repeating point, it needs to again be at 0 but going upwards. At 0.002, it's at 0 and going downwards. So it's not a full wave. We've actually only hit half a wavelength. So that's why it's not 0.002. The actual answer, Geordie, you've got that right, is 0.004. Because we've got one full cycle before the wave now repeats again at this point. So if I put a line there, that is where the wave repeats again. Yeah? So the answer is 0.004. Okay, and then part F, determine the frequency of the wave shown in figure 3. Use the physics equation sheet. So in this case, they haven't told us the equation in the question, yeah? But you know it's one that you're given in your formula sheet. So in this case, what I can do is I can go back to our notes, and there we go. We have an equation for frequency and time period. Period equals 1 over the frequency. Yeah. So we have that. That means I can go to this and say we want the frequency of the wave. So we just saw that period equals 1 over frequency. So in short, t equals 1 over f. So having seeing what we got here, we've got the time period as 0.004 from the previous question, and we now want to find the frequency. So what we can do is rearrange this equation to find what frequency is, and to do that we simply can swap the frequency and the time period. So frequency is multiplied to the left hand side, and then you divide by time period to bring it over to the right hand side, which means they essentially flip around, so you get frequency equals 1 over the time period. So that means it would be 1 divided by 0.004. So what would that be equal to? Can anyone tell me? Afghan, yes, this is paper 2. Correct. 250, correct. Yeah, so the answer is 250 hertz. Thank you for that. Good. Okay. Now we'll take a look at one more question on this before moving on to electromagnetic waves. So we covered all 3 topics. So, sorry, go back on that. The wave shown in figure 1 has a frequency of 4 kilohertz. So this is a continuation actually from the previous question. Apologies. So now it tells us calculate the period of this wave. So if we've got a frequency of 4 kilohertz, what would the period be? We've seen from the previous question that period equals 1 over frequency. So t equals 1 over f. And it's exactly in the format that we want it, because we are given the frequency. So, what should I do to calculate the time period here? So Geordie said 2,500. That wouldn't be correct because we're doing 1 divided by the frequency. So it's 1 over the frequency of 4 kilohertz. The first thing I actually wanted to point out is that it's kilohertz. Yeah, the standard unit for frequency is hertz. So what would the conversion be to turn it from kilohertz into hertz? Anyone know? Times by 1,000, Tina, correct. Both of you are correct. Yep, all of you said 1,000. Correct. So that would be that we would need to do 4 times 1,000 to get 4,000 hertz. Now we're in what we call the standard units to be able to calculate the time period. Yeah. So now we're doing 1 over f, so that would be 1 over 4,000. And therefore that is equal to a small number, right? What is that number? .0025. I think you're slightly short there, Geordie, because it's 4,000. So dividing by 4,000 is like dividing by 1,000 and then dividing by 4. The answer is that you're missing 1 0. It's 0.00025. Now, as it's the time period, they've also asked me for the unit. So what would the unit be? You struggle with half equations, Elijah. That's fine. That is obviously a chemistry topic. And with that, you can go into chemistry in our notes and it will be there for you to revise with. So head onto the website and take a look. Hopefully it will help you. I'm sure it will. Seconds, correct. Yeah, the unit is seconds. Hertz is the unit for frequency, Alex. So they've asked for period, so it's going to be in seconds. So the answer would be seconds. 0.00025 seconds. Cool. Now we'll move on to our next topic, electromagnetic waves, types of electromagnetic waves. So you can see here that the different types and all of that are in the notes here. So anything again related to the questions I'm about to go through, you can look at the notes and then cross-reference that to try and answer the questions. Yeah. So question 1. There are different types of electromagnetic waves. What do all electromagnetic waves transfer? Is it charge, energy, matter, or sound? Earlier I mentioned electromagnetic waves are a type of transverse wave. And we spoke about earlier, what do they do? Yep, I see a couple of answers. They are correct. It is to transfer energy. Good. What website is this? This is flashrevisionlab.com, Rupesh. Head over there. You can, all of these notes and these questions you can access for free. But if you sign up with a subscription, you also get access to the live classes that we do, where we'll be going through the content in more detail. So yes, Rupesh, it's free for the questions and notes, all the notes and videos, all the things I'm showing you here right now. This is all for free. Yeah, you can do this literally right now. You can head over to the website and do it as we speak. So yeah, feel free to use this. It's a great tool. I'm sure it will help you in terms of practicing for your exams. So, second question. Complete the sentence. Choose answers from the box. Different types of electromagnetic waves have a different blank and a different blank. I'll come back to this question then, as Rupesh has another question. I'll just answer that quickly. How can you distinguish between combined and triple? It's simple. If you go to the top right, if I just bring this down a bit, if you go to the top right, there is, and I go to revision for each subject, so you can see for physics, same for chemistry, same for biology, you can click on combined or triple and it will show you the list of topics that are in your list. So for example here, I've gone to GCSE combined. So you can see as I go down, these are all the topics that are in combined. Topics 1 to 6 here. Yeah. So that's how you get to it. Cool. So I'm back at the question. I see a couple of answers there. Frequency and wavelength. Yes, that is correct. Yeah, because EM waves don't have a charge, so that rules that out. They don't change in speed because they all have the same speed, which is the speed of light. Yeah, so they don't have different speeds. So therefore the answers would be different frequency and different wavelength. Correct. Rupesh, glad to hear that. Yeah, head over and try it out. So the diagram below shows the electromagnetic spectrum. Give the names of parts A and B of the electromagnetic spectrum. Sorry, I'll bring this back across. So the diagram below shows the electromagnetic spectrum. Give the names of parts A and B of the electromagnetic spectrum. So we have radio, microwaves, infrared, blank, ultraviolet, X-rays, and blank. Geordie, I hope you can see now. Just let me know. I think it's centered. Sorry, I was off center. Anyone have any ideas on what this is? So Sophie, you've said visible light. Is that for A or for B? So obviously there's two. So you've got gamma ray as well. So Sophie says gamma ray and visible. Anyone have any difference? So visible for A, yep, you're both correct. That would be visible light. So A is visible light, and then B, correct, is gamma rays. Well done. Nice. So in this, you need to remember the spectrum. You'd also go through what the uses of each type of radiation EM waves are, their uses and their dangers. So knowing the spectrum inside out is important for this topic. Cool. I'll go on to question 2 then. So the diagram below shows types of waves within the electromagnetic spectrum. Some of the types of waves are represented by letters. Which letter shows the position of UV radiation, ultraviolet, within the electromagnetic spectrum? As you can see, P is there on the left. You've got Q, R, and S. So P is at one extreme end of the spectrum, so a complete opposite end of gamma rays. So that is actually radio waves. We've got Q, which is between microwave and visible light, that is infrared. And I can see it's all everyone's saying it in the chat. R is next to visible light, and that is your ultraviolet, because S is X-rays. So R is the correct answer. Good. Then a special lamp can produce UV radiation. Which two statements describe the electromagnetic waves emitted by a UV lamp? Tick 2 boxes. So it says they have a higher frequency than X-rays. They have the same wave speed as visible light. They have a longer wavelength than microwaves. They have a lower frequency than gamma rays. And they have a greater wave speed than radio waves. Which two of these will be correct? You can say 1, 2, 3, 4, 5 or A, B, C, D, E. A lot to type out one of the answers. So. Any answers, anybody? Don't be afraid to get it wrong. Just give it your best shot. If you're wrong, then you'll learn it for next time. Yes, Rupesh, these questions are extracted from past papers, so it's giving you exactly the knowledge that you need. So go through the notes, come to these questions, and it's the perfect prep for your exams. So you've got an A and C, so the first and third one. Charlie said definitely 4. Spader said lower frequency than gamma. So a lot of different answers, 1 and 5, 1 and 4, 4 and 5. Plenty of different answers there. Saved my GCSEs last year, glad to hear it. Hopefully we can help a lot more people this year. So a variety of different answers have come in from people. So let's have a look at which one is the correct one. So this is for UV, yeah, for UV. So have a higher frequency than radio waves. A few people have said that. If you look at the spectrum, which they've given us up here, I'll put the order up here. So gamma rays have the highest frequency. So we know that if we go from right to left, the frequency is decreasing. So as I go further along here, the frequency is going lower and lower. So that means gamma rays, X-rays, UV rays. UV has a lower frequency than X-rays. Yeah, so 1 isn't correct. See some more answers, 2 and 4 or 4 and 6. Okay, several answers that you're coming up with there. I think I can understand why, but we'll go through and kind of go through each one and explain whether it is or it isn't. So it's not the first one. They have the same wave speed as visible light. So I did briefly mention this earlier. All the EM waves travel at the same speed, the speed of light. So this would be correct. They have a longer wavelength than microwaves. So if I come back to the spectrum, I said the frequency is decreasing as you go from right to left. That means that also if the frequency is decreasing, you see less waves. Earlier I was saying the wavelength would therefore increase as we're going this way. So lambda I've used there is the symbol for wavelength, will be increasing as you go from gamma rays through to radio waves. So if we go back to here, it says that UV has a longer wavelength than microwaves. Microwaves is further along to the left, so actually microwaves has a longer wavelength. This is incorrect. They have a lower frequency than gamma rays. So if we come back to this, I did say gamma rays has the highest frequency. UV is after that, so it has a lower frequency. So this is correct. And just to double check, they have a greater wave speed than radio waves. No, that's not true, because again, as we said for The second one that we've ticked, they have the same speed. All EM waves have the same speed. So that is incorrect. So we have our two answers. Yep, they have the same wave speed as visible light and they have a lower frequency than gamma rays. Nice. So I think that probably is a good place to leave it for today. Thanks all for joining. If you found it useful, great. If you want to learn more on these to make sure you're prepped for the exams, then come along on Sunday and we will go through these three topics in more detail. Someone's asked, can you do one more? I guess why not? If you've got the time, then we'll quickly look at one more. Let's have a look. Question 3. So, infrared has a range of wavelengths from 700 nanometers to 1 millimeter. Which part of the electromagnetic spectrum would have waves with a wavelength of 6.5 times 10 to the minus 7 meters? Tick the correct answer in the box. So that's 6.5 times 10 to the minus 7. So first of all, we need to be able, they've mentioned two different types of distances here, well, or they've used different units. Yeah, so we need to be able to differentiate between all of them by comparing them with the same units. The best way to do that will be to, I would say, keep them all in meters. Meters is our standard unit of measure. So we'll keep the wave they've mentioned, 6.5 times 10 to the minus 7 in mind. 700 nanometers. Does anyone know what a nanometer is in meters? These conversions come up frequently. Obviously, we talked about kilo and kilohertz earlier in these questions, but here we've got nano. So nano is a lot smaller nano is a lot smaller than kilo. It's actually even smaller than milli. So nano is, as the name kind of sounds like, the easy way to remember it. No, Sev, it's not 1,000. Nano is 9. It's like 9, so it's 10 to the power of minus 9 is a nanometer. Yeah. So you take the nanometers and times it by 10 to the power of minus 9. So that is 7. Oh, sorry, come off that. Oh, let me deactivate the pencil. Sorry. That's just my hand. I think my hand's on it. So I'll explain this. So 700 nanometers would be 700 times 10 to the minus 9 meters, which is therefore 7 times 10 to the minus 7 meters, yeah, if we add the zeros. 1 millimeter, that would be 1,000. Sophie, I don't know if you're referring to that, but that would be divided by 1,000. So that would be 1 times 10 to the minus 3. So we've got a big range there. 6.5 times 10 to the minus 7, where does that sit? Does it sit within this range or does it sit outside of this range? So we have 700 times 10 to the minus 7, which is 7 times 10 to the minus 7. That's on one end, but this is 6.5 times 10 to the minus 7. So it's actually shorter. So if it's a shorter wavelength than infrared, what type of wave has a shorter wavelength than infrared? It's not in the range, so we discount infrared. Microwaves are longer. 6.5 is shorter, so it's not microwaves. That's why that's incorrect, because a microwave has a longer wavelength than infrared. This 6.5 times 10 to the minus 7 is shorter than this range. So that's why it wouldn't be microwave. I hope that makes sense. Radio, again, is longer. So again, for the same reason as microwaves, it wouldn't be radio. So therefore, by process of elimination, it leaves us with visible light. Yeah, visible light is next to it in the spectrum. If I go back to the spectrum, you can see here, you can if I move across, sorry. In the spectrum, as you go from radio to gamma, the wavelength is getting shorter and shorter. So you've got infrared and you've got microwave that's longer and visible light that's shorter. This wavelength is shorter in this case, so therefore it's visible light. This is something that does sometimes come up, Sophie. The key thing is to remember the spectrum. Once you remember the spectrum, then hopefully that avoids your confusion going forward. So again, that comes with practice. So reading this over, trying questions on it, and that's going to help you to remember these. So yep, the answer is visible light in this case. Does gamma have the highest energy? It's a good question. It's not something that you kind of learn in this specification at GCSE. It's something that you refer to more at A level. But if something has a higher frequency, it has a higher energy. So it would be that gamma has the highest energy of all of them. But yeah, that is not something that you need to know for this. You will see that because in here it's not mentioned in the notes. You can also refer to the spec. If I go to the spec tab here, and it will tell you what you do and don't need to know. It doesn't mention anything about knowing the energies, so that is not needed. But yeah, good question. Fine, I think we've done that, so we'll leave that there for today. Thanks all for joining. I hope you did find it useful. But yeah, do come along to Sunday's class where I'll go through the notes in detail, and you can get the workbook and go through the notes, and hopefully when we do questions in that session, it will make even more sense to you guys. But other than that, have a good evening and take care. Cheers all.